Now, in the example that we've just covered, we've dealt with only one independent variable. But the nicety of two-way analyses of variance, or analysis of variance as a technique more broadly, is that we can actually look at how multiple independent variables combine to affect a dependent variable. And section 8.6 discusses this in the context of looking at two independent variables. So the example that we're going to use as an illustration of this is if I want to know what the effect is of being distracted, as well as the effect of the complexity on a task on decision making, then I've got a two variable situation in which I have IV1 being distraction, you're either distracted or you're not, and complexity of task being either complex or not complex. And then I'm going to look to see how combinations of those variables affect decision making. And so in a two-way analysis of variance, I can talk about two basic kinds of effects. A main effect is how I discuss the effect of one variable when I'm ignoring the other one. So in the context of our example, I want to know just what's the effect of distraction. I want to ignore complexity and I just want to look at distraction. This is called the main effect of factor one, or the main effect of distraction. I can also ask what's the effect of task complexity if I ignore distraction. Okay, so these are main effects. But the interesting effect in a two-way analysis of variance is always the interaction term. This asks the question, does the effect of distraction depend on complexity? Or does the effect of complexity depend on distraction? And we can visualize this by looking at the following bar graph. Here I have my decision-making method. I'm either distracted or I'm not distracted. And then I have the complexity of the task. I have the blue bars indicating a less complex task, and the pink bars are kind of reddish bars denoting the more complex task. And so I can see here I don't really have much of a main effect. If I were to stack these blue bars on top of each other and compare them to the pink bars stacked on top of each other, that would give me my kind of main effect of complexity. Likewise, if I were to kind of just look at the bars here and compare with them here, it doesn't feel like I have that big of a difference between unconscious and conscious decision making. This is the extent to which we're distracted, and this is the extent to which we are not distracted. But my effect is actually driven by the interaction between these two variables, and I can tell there's an interaction because I have a crossover. Okay? This is a telltale sign that we have an interaction. The effect of decision-making method definitely depends on the complexity of the material, or put differently, the complexity of the material, the effect of complexity definitely depends on the decision-making method. So when I'm in a conscious decision-making environment, when I have the time and the ability to really pay attention to things, I do really, really well. Okay, on less complex tasks, and not so well on more complex tasks. But counterintuitively, when I'm distracted, okay, I actually do better with the complex task than I do with the less complex task. And so this is just a demonstration of how we can use analysis of variance to look at combinations of variables. What I mean by combinations of variables is that the people that generate this average, okay, these are people that are exposed to conscious, less complex tasks. Likewise, these are different people that are exposed to conscious, more complex tasks. That's what I mean by a combination of variables. Now, you're not expected to do a two-way interaction in your homework this week, but I do want you to just be aware of the fact that analysis of variance can look beyond just a single variable to look at how variables combine to affect a dependent variable.